The second half of our first success criteria is learning how to translate between word and chemical formulas. But before we do that, we need to review how we know a chemical change has occurred. And this content was covered in semester 1 in our matter unit. One of the things we can actually see when a chemical change has occurred is that there's a change in color. So for example, we can start with clear liquids and make white solids or make blue solids. And these solids are known as precipitates. Another visual clue that occurs when there's a chemical change is that bubbles produce, so gas is formed. And one of the more exciting visual clues is that light is produced. Like when we react magnesium with oxygen, a bright white light is produced. Another clue that we can feel but cannot necessarily see is that there is an energy change and that heat is absorbed, and this is called endothermic, or heat is released, and this is called exothermic. Another piece of review is about chemical equations from the first half of this success criteria. So chemical changes always involve the rearrangement of the way atoms are grouped. This sentence implies that no atoms are lost or gained. So a chemical reaction is one or more substances are changed into one or more new substances by the reorganization of the component atoms, or the reactants. And we visualize chemical reactions through chemical equations. So a chemical equation is a representation of a chemical reaction that uses the formulas of the starting substances that react. So these are reactants, and the new substances that are formed, which are our products. I want you to notice that the reactants and the products are different because we're creating new substances. So reactants will always be on the left side of the arrow, while products will always be on the right side of the arrow. But when we write chemical equations, whether it's in word or formula versions, we have to be aware of additional symbolism that might occur. So when we see an arrow, it points from the reactants to the products. And the arrow acts as our dividing line between what we're starting with and what we're ending with. And it can mean a lot of different things, but most commonly is we'll say yields, creates, or produces. When we see a plus sign, that shows that there's more than one product or reactant, and it means and. If we see a triangle or a delta symbol over the yield arrow, that means heat was applied to the system, or that we heated something up. If we see a chemical symbol, not necessarily just platinum, but platinum is a really common example of this, that means that a catalyst was present. So in biology, when you spoke about enzymes, those were catalysts of reactions happening in your body. So a catalyst speeds up the reaction. So it's a substance that speeds up the reaction. And we can abbreviate reaction as RXN, but does not become part of the end product. The symbol we'll see a lot after a chemical formula is an S, and that stands for solid. Sometimes we'll see L, and it's if a compound or an element is in liquid form. And to be quite honest, we're only going to use this for water, because water is the only pure liquid we will be working with. Everything else is technically dissolved in water, which we'll get to in just a moment. If we see a little G after a chemical formula, that means that it's in a gaseous form. And if we see something that says AQ, this stands for aqueous. And this is in a liquid form, but it means dissolved in water. So any other liquid that we handle, if it's not pure water, is going to be aqueous. Now, before we move on, we need to talk about something called diatomic molecules. So we're going to need to add this to the bottom of your note sheet. And if you look at the parts of diatomic, we're going to see that there's a really common prefix. So this means two. And then atomic stands for atom, or two like atoms. So there are specific elements that are only stable as a pair. And they make a really, really neat acronym. And we say it's Brinkelhoff. So bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. So whenever you see the word bromine, it's not just one Br, it's two. Whenever you see the word iodine, it means I2 and not just one I. Whenever you see the word nitrogen, it means, you guessed it, N2 and not just one N. Chlorine, typically in a gas form, means two Cl's, not just one. Hydrogen, whenever we see the word hydrogen, it's not just one H, it's going to be two. Whenever we see the word oxygen, it's not just one O, it's going to be two. Whenever we see fluorine, you guessed it, it's not just one atom of fluorine, it's going to be two bonded to each other. So now we need to kind of dissect the following sentence to find not just the chemical formulas, but also determine which chemicals are reactants versus the products. So what I'd like you to do is I'd like you to pause the video and find 3 different colored pens in addition to the pen or pencil you're using now. So the sentence states, once lit, the methane gas, CH4, coming out of a Bunsen burner, reacts with the oxygen in the air, producing carbon dioxide gas and water vapor. The first thing that I'm going to do is I'm going to highlight the chemical formula names that I see and their states of matter. So solid, liquid, or gas. So I see methane gas, okay, and it comes out of a Bunsen burner and it reacts with oxygen in the air and it produces carbon dioxide gas and water vapor. Okay, my next step is I'm going to find any words that help me indicate. So I'm going to highlight a different color. So for example, reacts with kind of implies, because I really have to read into this, that methane and oxygen are my reactants, what I start with, and then I see the word producing, so that means that that is telling me what I'm about to make, so the new stuff, and then I see the word and then that kind of tells me that there's more than one product or more than one thing I've ended with. So then the next step that I'm going to do is I'm going to highlight in my third color my reactants, or I'm going to underline rather, in one color so I know which one is which. So I think that methane gas and oxygen in the air, and the reason I know I have a feeling that these two are my two reactants is because of this phrase, reacts with. And then with my pen or my pencil, if I'd like to get a fourth color, I can. I'm going to underline my products. So the helpful word that I saw of producing is letting me know that I'm about to talk about my products, what I'm ending with. So these are my two products. So my next step is I'm going to move the words down to these really helpful boxes, and then I'm going to translate based off of my knowledge of nomenclature rules. So I first have methane gas, and then I have oxygen, and it says in the air, so I think that's a gas. And I also have carbon dioxide as a gas. And then I have water, and the problems say that it was a vapor. And I have to think really hard. Vapor is what state of matter, solid, liquid, or gas, and it's a gas. So now what I'm going to do is I'm going to translate these words into their formulas. So in my problem it says that I have methane gas, and it gives me a formula. So that one's easy to start with. So it's CH4, and because it's a gas, I will need to use this symbol after the formula. So we write a little g down here. My next chemical is oxygen, but we just talked about oxygen in the form of a diatomic molecule. So it's not just O, it's going to be O2. And because it's also a gas, we're going to put a little g down here as well. My next chemical is carbon dioxide. So the di reminds me of the prefixes, which is correct because it's a covalent compound. So carbon is C, and then dioxide is O2, and then I have a little g here for the gas. And water is H2O, and because it's in a gas state, I also have to put a little g. So you might be wondering, like, okay, well, it's gas for all four of them, and do I really have to write it each time? And the answer is yes. So our sixth step in our process is actually putting it all together. So my reactants have to go on the left side of the arrow. So those are CH4, and that's a gas. And then we have our reacts with, our plus sign. It's kind of like our and. So methane gas and oxygen, or methane gas reacts with oxygen in the air. So O2 is a gas. And it produces, so yields, produces, creates is my arrow. And then I have my products of CO2 gas and water vapor, which is just water in a gas form. So while that might seem like a significant amount of work, the more practice we have, the more efficient we'll become at this particular skill. And so you have two problems to do on your own as the your turn problems. On the opposite side of the page, we're going to learn how to go from formula to word. Now, this one is a little easier to determine what the chemical formulas are, as they're pretty explicit. So actually our first step when going from formula to word is to actually move the formulas down to the boxes. So I see I have CaCl2, and it says AQ. And then I have Na3PO4, and that also is AQ. Then on the other side of the arrow, I have Ca3PO4 2. So right now I'm just copying down exactly what I see, and there's an S. And the last formula I see is NaCl, and it's AQ. So my second step is to translate in the opposite box. So Ca is calcium, and that's a metal. It's on the left-hand side of the periodic table. So because it's a metal, I have an ionic compound, so I have to follow that particular nomenclature rules. And then Cl is a front side element, it's chlorine, so I have to change the ending to chloride. But then this sneaky little guy here, AQ, going back to the front side of our note sheet, AQ stands for aqueous or aqueous. So that actually goes in the beginning. So that's why he's kind of a sneaky little guy. So now that I know that, I'm looking at my next formula and I see that there's AQ over here, so I'm going to write that first. And I look at my first element and it's Na, and Na means sodium. And sodium, after looking at the periodic table, is on the left, so it's a metal, which means it's ionic. So I'm just going to write the full name of the cation, or the first element. And then I notice that the rest of this is a lot of letters, which leads me to believe that it's a backside element. So after flipping my periodic table over to look at my polyatomic ions, I'm scanning the list, and I find PO4, and then I have phosphate. Now, as a pro tip, what's really, really neat is that once you determine the names of the parts of the reactants, they don't change in the products, like 99% of the time. Because remember, atoms aren't created, so you're not getting anything new. Atoms aren't destroyed, so like nothing's going to go away. The pieces are just rearranged. We have the same parts, just in a different order. So in this next one, this S stands for solid per the front of my note sheet. So I'm going to have a solid here. Ca is still a metal, and it's still calcium, so I can just put that on there. And then the last piece of that is phosphate. Because remember, the pieces don't change, they're just in a different order. So then in the last chemical formula, we're back to AQ. You're going to get really used to this because a lot of times in chemistry we work with solutions or aqueous things, like things that are dissolved in water. So it's a liquid, but it's not pure water, so we can't say it's a liquid. And Na still stands for sodium, and then Cl is chlorine, so we change that ending to chloride. So that what you're going to do, our third step, and that was a really long second step, so I appreciate your patience, but our third step is we're going to follow the chemical equation. And we're also going to translate the symbols now. So for example, we have a plus sign, and in its most basic form it means and I have another one over here. But then this arrow can mean one of three things. If I look to the back of my note sheet, it can be yields, creates, produces. Note that equals was not one of the options. We're going to choose one of the three options for now. So produces is fine. So just to kind of let these stand out a little bit more, highlight them. So now what we need to do is we need to take our word equation and we're going to put it in the same order as the chemical equation that we were given. So because we're just starting off, we're going to start with a really basic format of this. So let's say aqueous, calcium chloride, because that's my first chemical formula and it's my first thing I translated. And then I see the plus sign, so we said that was and. So then I have Na3PO4, and I translated that as aqueous sodium phosphate. Okay, so now I'm at my arrow, and it means produces. And so now I'm at my first product, which was Ca3PO4, and so I translated that as solid calcium phosphate. And then I'm at my next plus sign, we said that means and then NaCl with an AQ, and it was our last chemical formula, and we had translated that as aqueous sodium chloride. So now for the rest of class, the expectation is that you're going to be working on the your turn problems on both sides of the sheet, and whatever you do not finish will be homework. The IP that's addressed with this, we will do that in our next class. And if you have any questions, as always, message me on the Remind app or shoot me an email. Thank you so much and have a wonderful day.